Factoring trinomials using the rainbow method, example 7. Sometimes we have expressions where the leading exponent is greater than 2. And this example will show how some of those can be factored. Our standard form we've been working with is ax squared plus bx plus c. But there are some values here that we don't normally write down. And you'll see these in red. We usually don't write down values of 1. Anytime you write down a variable or a number without an exponent, the exponent present is going to be a positive 1. Also, any variable with an exponent of 0 also equals 1. And again, we don't normally write down values of 1. But still, we need to be able to see or know that these values are present, but not always written down. So in looking at our standard form, what is the pattern of these exponents? See the first term, the exponent for the variable is a 2. For the second term, the exponent value is 1. And for the last term, the exponent value is a 0. So one way to describe the pattern is 2, 1, 0. But there's also another way to describe this pattern in a more general form. The first term, its exponent value for the variable is even. For the second term, the exponent value is half this. And the last term, the exponent for the variable is a 0. So the pattern could be even, half, and 0. So the expression ax to the fourth plus bx squared plus cx to the 0 would fit this pattern. The first term, the 4, is even. The second term, the 2, is half of this value. And the last term, it's a 0. It's not present. The expression ax to the sixth plus bx cubed plus cx to the 0 also fits this pattern. 6 is even, 3 is half this value, and 0 is at the end. And this sequence can be continued on without limit, showing even ax to the 8th plus bx to the 4th plus cx to the 0. It's the pattern of even, half, and 0. So let's look at the expression 3x to the 4th minus ax squared minus 3. Our first step is always to write the expression in standard form, but we'll use the more general form of the exponents, where we have the first term, the exponent is even, the second term, the exponent is half of this value, and the last term, the exponent is 0. And we see in our expression here, the first term, the exponent is a 4. The second term, the exponent is 2, which is half this value. And for the third term, the variable is not present. Its exponent is a value of 0, which would generate a 1, which normally wouldn't be written down. So our expression does fit the more general pattern of the exponents. So we'll use the rainbow method then to try to factor. Next step is always to find a, b, and c. A is a 3, b is 8, c is 3. Next, we need to multiply a times c. So a times c would be 3 times 3, which would give us 9. Now we need to find all the factor pairs for 9, starting with 1 times 9. And we'd have 3 times 3, and we found all the factor pairs. Now we need to link our factor pairs together. So the 3 and 3 are linked together, and the 1 and 9 are linked together. Now we need to find the sum and difference for each factor pair. We'll put the sums in the upper corners and the differences on the lower corners. So for 1 and 9, the sum will be 10, and the difference will be 8. For 3 and 3, the sum would be 6, and the difference would be 0. Now we need to locate b and mark the pair that's used. b in this case is equal to 8, and we have an 8 on the lower corner down here using the factors of 1 and 9 to form the 8. Now we need to rewrite the expression with this pair. So we'll write the first term and the last term, leaving the space in between that we're going to fill in. The middle term is a negative 8x squared. We're trying to split that two factors that we found. Using the 1 and the 9, we have 1x squared minus 9x squared. These are like terms with the original term we're trying to split. And combined together, the plus 1 minus 9 will give us a negative 8. Now we need to factor by grouping. We have the first group and the second group. Looking at the first group, the common factor for these is x squared. We factor it out, we're left with 3x squared plus 1. For the second group, we can factor a negative 3, and a 3x squared plus 1 remains. Checking inside the parentheses, both these expressions are identical, so we can continue. And we'll factor out the 3x squared plus 1 for the first factor, and the remaining factor will be x squared minus 3. So let's multiply our factors to check using the FOIL. So for the first, 3x squared times x squared gives us 3x to the 4th. The outer, 3x squared times a negative 3 gives us a negative 9x squared. The inner, 1 times x squared is x squared. And for last, a 1 times a negative 3 gives us a negative 3. Combining our like terms together, we get 3x to the 4th minus 8x squared minus 3. And this is the original expression that we started with, so we did find the factors for this expression.